Hi everyone, welcome back to the Linux. Today we are going to see about Bernoulli's Naive Bayes algorithm. It is in a supervised machine learning and used for a classification task. And it's also in a type of Naive Bayes algorithm, and it will works based on the Bayes theorem, and it works on the discrete data like words, strings, you know, and the classification of features like always yes or no, like binaries, zeros and ones. It will take in a probability. If the words occur in that class, it's taken a success rate. If the word doesn't occur in that class, it takes a failure rate. We will understand this once we go for a dry run. What is Bernoulli's naive Bayes algorithm? It is used for a binary future presence. If the data is present, then we take in a success rate, right? If the data or if the word is doesn't present in that class, we take in a failure rate like 0, and it is suitable for a text classification in the words, and each features in the model is in a binary value. If the words are present in the class, we take as in a 1. If it doesn't present, we simply take as in a 0. And after finding these binary values like zeros and ones for each features, we apply some Bayes theorem with an independent assumptions and find the overall probability of a given data belongs to each class or not. This is the Bernoulli's prediction formula. If I write the equation, it's like bit confusion, right? For a Bernoulli's equation, it looks like f of x equal to p of x q of 1 minus x. The x or belongs to 0 and 1. These are the discrete. So I put this bracket. These are the discrete, 0 otherwise. Mostly there is no cases. It occurs 0. In the Bernoulli's, there is two cases. Either the pos zeros or in a ones. For example, if there is a 0, this means we know that if the word present in that class, we take as a 1, right? If the word doesn't present in that class, we take as a 0, right? If the word present in the this is a Bernoulli formula, and it will use for an a find the probability of that word belongs to that class. If the let's take in a class, the class contains some words. Now occurs one times, and word like offer. Offer occurs one times, and money occurs 0 times. For a new input like x equal to now money, it doesn't make sense. For simplicity, for an example, we take that if the for finding the probability of an x belongs to this class, like the class 1, we simply use this Bernoulli's formula initially, and after finding its probability, we use the Bayes theorem to find the overall probability of the x belongs to that class. First, we find the probability of a single word belong to those classes. As you can see, the this data is separated by the each words, and each words have an independent to each other, and we first find the probability of a now in this class. The now it's present in one time, right? Let us assume the probability. We find the probability if the data is 1 based on some formula. I will tell you that formula later. For any simplicity, we for the now the belongs to in a class 1 as in a probability of 0.25, and it will return 0.25. This is how it will return was here the now is present in that class, right? So it has taken as 1. So in this equation, P of x, Q of 1 minus x. Here for an now it is present in the class 1, right? So we take as in a 1, x as in a 1. So if we substitute x as in a 1 in this equation, it looks like P of 1, Q of 1 minus 1. This term will be in 0, right? And 1 minus 1, anything power, see anything power 0 is 1, not 0. And it will give us a probability of success rate. You can see that P is in a probability of success rate and Q is in a probability of failure rate. Similarly, if for an future like now, sorry, money, there is a no occurrence in the class 1, right? So the formula will be P of x and Q of 1 minus x. Here it is, money is not present in that class, right? So the x will be 0. So if you substitute x will be 0 in this equation, P of 0 into Q of 1 minus 0, that is Q of 1, and this 0, P, anything above 0 is 1, that is 1 into Q. As I told, Q is in a failure rate, right? It will take the failure rate of that class. So similarly, it will find for a number of class present in the model, and after finding the each of its probability, like each of the words in the given input, it will find all the probability separately in each classes in each words. And after finding the probability of all the things, or we can say that all the classes, then it will find the overall probability of a data belongs to each classes by a Bayes algorithm. Sorry, we can say as Bayes theorem. This is a x of I. You know the x of I is the, for this is a probability of a two case like present or not present. But in the machine learning model, there is a n number of futures, right? So we put in a I and we multiply them, like there is n number of future. We need to iterate them. So we use big pi here. It is similar to in a summation, but in the summation we are add them, but in the big pi we multiply them. This is a conditional probability of an x of I equal to 1 of given c, and it will find the probability of a word appearance. Let's see that. This is a probability formula. As I told, it will find the probability using some formula, right? Here I told that something 0.5. Here we can see that how it will find the probability. First, it will take that word like now or a name, money, offer. It will take that word and find the number of occurrence in that class. And after finding the occurrence, it will add them with some alpha. This alpha is called as Laplace smoothing. Usually it's 1. The formula will be looks like in the numerator number of words, sorry, number of frequency of the word in the class C plus this alpha, or called as Laplace smoothing. Usually this value is 1. And in the denominator, the NC. The NC are nothing but the number of documents in the class C. For example, there are thousands of datasets, 1 to 1000, and in the 1000, 500 datasets are class 1 and another 500 are class 2. Here it is, the for in a class 1 the NC is 500, for in a class 2 the NC is 200. For example, it will extend like it will this we will extend this dataset into in a 1500, or we can say 1600, and this 600 are considered to be class 3. For an a NC for an a class 3 is 600. Usually the NCs are number of documents in the class, and 2 is in a 2 alpha. You know that alpha is in a Laplace smoothing, and why here is 2 was because it's in a Bernoulli's binaries of in a futures, right? It's either 0 or in a either 1. So we multiply with in a 0 plus 2 alpha. This is in a formula will looks like. you will find the frequency of a word and in that class, and add within a Laplace smoothing and divided by number of, number of datas in that class, or we can say that number of inputs for that class plus 2 into Laplace. If you divide them, the whatever value you get, it considered to be in a probability if the data is present as in that class. Let's see in a quick dry run. It will make you to better understanding of this model. Let's take in a training data set. This is a training data set, and document one is in a win money now, and document two call now, and have a lunch today, and let's have a lunch. These are the data and corresponding labels: spam, not spam, ham, like that. And in the vocabularies, we store the unique data like unique words in this, like win money. It doesn't contain a duplicate. For example, here it is now, and here it is now. There is occurs two times, but in this vocabulary, there is only one times it will occur. And we find the probability of each word belongs to each formula by this formula. This formula, or nothing but, it is a Bayes theorem used for each message of a predictions. Futures probability with an alpha as one. This is an alpha one, as I told, it's usually one. First, before during the training process, what it will do was it will first separate its classes. For example, in this case, there is a two class in the entire data set, right? Two classes, and it will first separate them that two classes like this. These are the one class, and these are the another class, right? First, it will separate them like in the class one. These are the like in the class one. It will store the words, each word has an futures and its corresponding frequency in that class. For example, win occurs one times, money occurs one times, now occurs two times, and call occurs one times. For in a spam class, money occurs one times, and win occurs one times, now occurs two times. I think it's called win money now, and call occurs two times. Sorry, one times. The total number of words in the spam classes is like 5, right? Similarly, for a ham class, or you can say a spam class, it will store the words and its frequency. Let's see that. Have your lunch today. Let's have a fun. Have lunch today. Have this occurs. Have occurs two times. Lunch occurs two times. Two times. Lunch occurs two times. Today occurs one times. Let's occurs one times. There is 6 words, right? 1, 2, 3. 1, 2, 3. 1, 2, 3. So the total number of words in the class ham class is 6. Fine. First, during the training process, it will store the frequencies, and then it will find the probability. Before that, there is the probability. It will store the unique words in the both classes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here there is a common. is something common, right? The overall work hour is 8. Second, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. 4 for 8. After finding this, we will need to find the probability of a money, like if it's present and if it's not present. For example, how we will find was, for example, probability of money present in spam class will be, as I told, the Bernoulli's formula, P of x and Q of 1 minus x, right? Here it is the money is presented, right? So we simply put 1, so the this rate will be 0, right? This will be 1 and this will be 1, x become 1. That is P of 1, right? And how will you find this probability? Success rate, right? And this, we need to find this probability, like word count in spam class plus alpha divided by nc plus 2 into alpha. As I told this formula here, where it is, I just erase it, right? No, no, here it is. This formula used for finding the probability, right? And using this formula, we find the probability. For example, for a success rate, the money is occurs one time, right? Yeah, money is occurs one time. So it will be 1 plus 1 divided by nc is 2, total number of votes. There is 2 class, the 2 votes, that is, so 2 plus Laplace smoothing is 1 plus 2 plus 2 is 4, that is 2 by 4, that is 0.5. The probability of money occurs in the spam class is 0.5. Similarly, what if the data not belongs to, what if the money not belong to that class? What is the probability? There is only two case, right? The word money either present in that class or not present in that class. So if probability of presenting in that class is 0.5, means what is the probability of that word not present in that class? That's also a 0.5. It's like, let's erase this. For example, the probability of money present in this class, we found that 0.5, right? For a better understanding, we take some word. For example, let's take win. The same formula. Let's take frequency of word or word count. Same frequency of word in spam plus Laplace smoothing plus nc plus 2 alpha, right? Here it is 1, word frequency is 1 plus alpha is 1 divided by 2 plus 2. Here it is same 2 by 4 and it's also in a 0.5. Probability of the win present in the spam class is 0.5. At the same time, the probability of win not present in the win class, that is failure rate, is also in a 0.5. Now let's see for an now, that is now as in a frequency of 2 and Laplace transform is 1, sorry, Laplace smoothing, and nc is 2 plus Laplace into 2 is also 2, that is 3 by 2, sorry, 3 by 4, that will be 3, 4, 4s or 3 eights, 4 eights are 24, that is, second, that is 0.75. 4 sevens are, yeah, 4 sevens are like 28, right? sorry, it's 28. 4 sounds are 28. So balance 2 and 7.5, 0.75 something. And probability of now present in the win class will be 0.75. What is the probability of now not present in the spam class? That is 0.25. How it will comes like if the probability of present that word will be some value like x. What is the probability? The value not present, that is q, that is in a success rate 1 minus x. If the probability of a being present now present in the spam class is 0.75, then the probability of being not present in the probability of now not present that same spam class is 1 minus whatever probability we get, that is here it is 0.75. If you subtract 1 minus 0.75, that will be 0.25. Similarly, we do for all this like it has some probability, usually 0.5. It will be, you know, it will be 0.75 as it is. It's also that same 0.5. It's also 0.5. If you do the calculation, it will like this. After finding the probabilities for each data in the each classes, we found that probability in the each classes, right? It is like, okay, we find the probability here, it is each classes, right? Using this probability, we can substitute during the predictions and finding the new data, whether it will be present or not present in the class. As I told, we found the vocabulary, right? These are the vocabularies. In this case, we simply use the arrays, like we found the unique words in all the data sets like this, in money now called like that, and corresponding values. For example, number of values like 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. This is an entire array of a size 8. Based on the input, it will be right. If the input contains the word win, then we put 1. If the input doesn't contains the 1, then we put 0. So it will helpful, like when you want to find the probability of any data belongs to that classes, or if you want to find the probability of data not belongs to that classes. As I told, if the probability of any data belongs to that class is 0.75, means if the probability of data and not belongs to that classes will be 1 minus, right? So we need to decide what probability it will get, right? So based on this array, we will find the probability of any words, whether it's want to belong to that class or whether doesn't want to belongs to that class, right? Here the size is 8. After finding these probabilities, like I put it there, after finding this probability, we go for any predictions. And during the prediction, it will use some theorem called Bayes theorem. In this Bayes theorem, we will be able to achieve whether the given entire words or which class it belongs to. For example, as I told, it will use some array, right? This is the array, and using this array, as I told, the win launch now. The win occurs first, right? As you can see that the win occurs first time. So in the given data set, it occurs win, right? So it will put 1 there. It will put 1 there and 0. 0, so I don't. 0 is money, right? Here in the corresponding value is money. The given words doesn't contain money, so we put 0 and lunch and now. Here it is, lunch occurs here, that is 1, 2, 3, 4, 5, 6, fifth position, and now occurs 1, 2, 3, right? So the win and now and lunch only have a value as 1. Other elements are 0, 0, 0. So the first position and third position and sixth position I have only 1, others are 0. Here you can see that first, fourth and sixth position. Sorry, first, third and sixth position I have a 1, others are 0. This means whether it's 1, we need to decide this data belongs to this classes. That means we need to find the probability. What is the probability the win belongs to this classes? If it is in a 0 like money, and what is the probability this money not belongs to this classes? If the word doesn't contain in that class means, or in the given text means, why don't we need the probability of a word that belongs to that class, right? If the word doesn't belongs to given word, sorry, if the word doesn't in the given message, like here it's prediction, win lunch, win lunch money, sorry, win lunch now, and here money is not present in the word, right? So we doesn't want to find the probability of in a money belongs to in a class spam or in a not spam class, right? In that case, if the word doesn't present in the given word, in that case we need to find what is the probability the money word cannot present in this class, so it will, you can understand that. And after finding this array, we use the pre-computed values, like the win is occur here, right? Win is occur in the word, so we put 1. After putting these values, we find the probability for in a class 1. For example, let's take 1 by 1. The probability of what? Win equal to 1. That means it needs to present in that class. And in spam class, right? Spam class, we found that probability, right? Win present into this class, right? That is 0.5. That will be 0.5. And money doesn't, money is here not its, right? And money doesn't want to find here, right? So we found that the probability of money belongs to that class is 0.5. See, so if we simply 1 minus whatever probability we get, we find the, that failure rate, right? Here it's also into 0.5, as you can see here. And we similarly do for a name one, that is now, right? What is the probability of now present in that class? That will be 0.75, and we put that 0.75, and then this term, what is that term? Let's see. Now call, if you see, the call is present, so but call it's not present here, right? What is the probability? It doesn't want to present in that class. That is 1 minus 0.5, and here also 0.75. And like, let's see this 0, that is here's some important, we don't have in this class. Actually, I do some mistakes. We found the vocabulary, right? Here it's vocabulary. After finding the vocabulary, we need to find the each classes, what is the probability it belongs to, and all the data are considered as a feature in both classes, and we only find the use the frequency there. For example, we here also we have an have, but the frequency is 0. But here as an have, but as a frequency 2, right? But here also have an a that word have and frequency as 0, so we can get the probability. And same way, whatever words are missing, like today as in a probability as in a frequency 0, and let's as a frequency 0. Similarly here also there is no money word, right? We put in a money word as a frequency as 0, because the money doesn't present in the amp class, right? And when also have a frequency 0, and call also frequency 0, sorry, it's 0. After doing this, we find the probability for there also, their terms also, that is, that is probability of have in the spam class. That will be 0 plus 1 divided by 4. Sorry, we have a frequency, but the probability will be reverse. Sorry, we have a frequency. Once again, Yeah, we have a frequency here also. Sorry, my mistake, my bad. Here also we have a frequency, have a 2, have a 2, but here we find the success rate, right? Whatever if it's one, but for an data which are not belongs to that class, we find this inverse rate, that is 0.75 and 0.25, and if you find all the terms, it will be 1 2 3 4 5 8, right? 1 2 3 4 5 6 7 8. After finding the probability, we similarly do for an AM class also. We get something called as 0.05, and in both cases, which probability as an higher? Here it is 0.0132 as an higher probability of in a spam class. So the message will be considered as in a spam class. That is Finland's now. This considered to be in a spam class. I hope you understand something in that. And that's it from this video. We will see on the next video. Thank you.